Welcome back to Transcended Institute. In today's discussion, we're going to talk about rotational motion. So I have a lot of questions with me here that are coming from tutorial sheet 9, that is under rotational motion, and this tutorial sheet is one of the most important tutorial sheet that you guys are supposed to know. So I've answered all the questions from question 1 all the way to question 10. We can clearly see that these are more interesting questions, especially starting from question 7 all the way to question 10. These are one of the most important questions that you are supposed to know before you go and write your test or before you go and write your exam. Okay, so let's begin our discussion with the first question. So the first question is saying a horizontally mounted wheel of radius r is initially at rest and then begins to accelerate constantly until it has reached an angular velocity of w after 5 complete revolutions. What is the angular acceleration of the wheel? So if you want to answer any question in physics, when you read the question, first come up with data. Data is going to help you to actually know the formula that you are supposed to use. Okay, so we can clearly see that they are talking about the angular velocity, of which we have not been given, but I'll just put which is w. Okay, but they are saying that it begins to accelerate constantly until it reaches at the angular velocity w. Okay, so one thing we should know is that the initial angular speed is going to be 0, but now the final is the one that we don't know. Okay, so it started initially at rest, meaning that the initial was 0 after 5 complete revolution. So we have got 5 complete revolution, but in most cases I want you to understand that we're going to be converting the revolution to the rad. So how do we convert? Okay, in one revolution we have got 2 pi rad. One thing I want you to understand that 360 degrees we have got 2 pi rad, then this is one complete revolution. So I will be using this conversion in physics, then in math we use these. Okay, so if you look at this point, now we can cancel the revolution and revolution can go. So I've got 5 times 2 pi. So using my calculator here, 5 times 2, so 2 pi times 5, that gives me 31.42. So now this is what we call the theta. So the theta is actually 2, or not 2, is actually, this is the linear displacement. So we have got the displacement that we call, I want you to understand this point. When we're talking about the velocity under linear motion, we're talking about v, but here we're going to be talking about w. Then the displacement d, here we're going to be talking about the theta. That's what I want you to understand. Okay, so in this case, this revolution, whenever they're talking about the revolution, we're talking about what? The theta. So converting this from revolution to rad, if I do 5 times 2 pi, I'm getting 31, which is 31.41, but in this case I'll just say 42 rad. Now the question is, we want to find the angular acceleration. Remember those formulas we were doing under linear motion, where we are saying the v final squared is equal to the v initial squared plus 2ad. The same formulas are going to be working, but in this case I'll replace this with this squared, then this with initial, then 2 acceleration we use alpha, then d is theta. So I want to find alpha. Final I don't know, I've not been given. Initial is 0, it started from rest. 2 alpha, I don't know. The theta is 31.42. So then I'll have 31 point that times 2, that gives me 62.83. 62.83, then times alpha. I'll divide here 62.83, here 62.83. Alpha becomes this squared. So that time we're talking about meters per second squared, but in this case it's lad per second squared. Why? Because this is in lad per second, so it is lad per second squared. So that becomes my answer. For the fact that I don't have the speed, which is the angular velocity, that's why I have just put it the way it is. Okay, so that's the basic idea behind it. This interesting question 1. Now let us go to question 2. So question 2 is saying a 250 ball is being swung faster and faster in a horizontal circle when the speed reaches 15 meters per second. The tension in the string is 500 newtons and the string breaks. What is the radius r of the circle? When something is moving at a very high speed, that's why they are saying faster and faster. Something is moving at a very high speed, meaning that the tension force is going to be directed toward the center. That's the tension force. But one thing I want you to understand, that whenever we're talking about centripetal force, when something is directed toward the center, that's the same as the direction of centripetal force. So in this case, centripetal force and the tension force are moving in the same direction. Therefore, the centripetal force is going to be equal to the tension force because they are moving in the same direction. So centripetal force is mv squared divided by r. In case you don't know, centripetal force is mv squared divided by r. Centripetal acceleration is v squared divided by r. Okay, I believe if you managed to watch my videos when I was talking about rotational motion, I explained everything, where the formula is coming from and everything. So this becomes equal to that. Our goal is to find the radius. So if you look at our data, we have got the mass. Now the mass here, it was supposed to be 250 grams. So that becomes, if I convert it to kgs, that becomes divided by 1000, that becomes 0.25 kgs. Then the tension force is 500 newtons. Then the V is 15 meters per second. If I cross multiply, I'll have TR being equal to mv squared divided by T divided by T. R becomes mv squared divided by T. So R becomes, what is m? M is 0.25 times V is 15, but we square it. I divide that by the tension force, that is 500. So my radius now becomes 15 squared times 0.25, that becomes 52.25. Now divide that by 500. So I'm getting my answer to be 0.1125. That is in meters. If you want, you can leave your answer in centimeters. So you have to do times 100 this one. That becomes 11.25 centimeters. So I can leave the answer there, or I leave it there. That is it for question 2. So let's dive into question 3. So question 3 is saying, if it takes, simple, right? It's saying if it takes a bike wheel 3 seconds to complete one revolution, like I said. So when I'm talking about revolution, in one revolution, there is what? 2 pi rad, like I said. So one revolution is already 2 pi rad. What is the wheel's angular velocity? So I have got the theta to be 2 pi rad, I've got the time to be 3 seconds, and my goal is to find the angular. This is the same with what we have been doing so far. Distance, I'll say speed. The formula for speed or velocity is equal to the distance over time. When we come to rotational motion, this speed is now w, d is theta, time is the same time, doesn't change. So theta is 2 pi, I divide this by 3. So this is in rad, this is in second. Our answer will be in rad per second. So now we have 2 pi divided by 3, that becomes 2.09 rad per second. That's the answer. Now let us look at question 4. A solid bowling ball of mass of 6 kg and radius r, that is 0.15 meters, is traveling at a linear velocity of v is equal to 4 meters per second. What is the angular momentum? So let's first talk a bit about angular momentum. What do we know about angular momentum? Okay. So angular momentum is represented by L, is given by inertia times the angular speed. But let's first talk about inertia. Inertia is given by different formulas. But if this question comes in your test or exam, they always give you the formula that you are supposed to use for inertia. Because inertia is given by they are going to give you different formulas. Because inertia, especially for inertia of the solid, okay, inertia of the solid ball, that becomes now is 2/5 times mass radius squared. But initially the overall formula for inertia is k mr squared. K can be anything. For example, I'll give you the formula for sphere. If we're talking about maybe a solid sphere, we realize that the inertia is given by, then k becomes half, okay, half mr squared. So now what I'm trying to tell you is that you don't have to master the formulas for what? For inertia. You are going to be given that inertia of this is maybe this. So in this case they didn't give us, but I want you to know that the inertia of the solid ball is 2/5 mr squared. Okay, but then I want us to understand something. There will be no test, no exam without using these formulas. I want you to understand that there are these formulas that we call under linear. There is what we call the linear velocity is given by the angular velocity times radius. The angular acceleration is given, or the linear acceleration, sorry. The linear acceleration, which is a, is given by alpha times r. Then the d, which is the linear displacement, is given by the theta times r. So in this case, if I can look here, I want to find the angular momentum. So what I'm going to do is, I don't have w, but I can find w using this. I can find v or w using that. So now I'm going to make w as a subject of the formula. I'll divide both sides by r. So that becomes, my w will be equal to v over r. So this inertia will replace it with 2/5. Then that becomes mr squared times, this becomes v over r. R will go, 1r will go, I'll remain with 1r. So this becomes 2/5, then m times r v. So if we plug in the values, the mass is 6, the radius is 0.15, the velocity is 4. So what will be the answer? So 2 divided by 5, 0.4 times 6 times 0.15 times 4. That becomes 1.44. Now, what are the SI units? If we look at this part here, this is in kgs, this is in meters, velocity is in meters again per second. So meters and meters will be the SI unit for angular momentum is kg meter squared per second. So that becomes kg times meter squared per second. That becomes the answer. So I want you to understand, you need to know this. You need to know this part. It's very important. This part is very important. You need to know it. Okay? So that is it for question 4. So let us dive into what we call rotational work, energy, and momentum. So it is still under rotational motion, but I want you to understand that it falls under rotational work, energy, and momentum. So how does it work? Okay, so this is under conservation of energy as well, but I want you to understand that if at all I have maybe an incline. Okay, so that's the incline that I have. I want you to understand one thing. Okay, so I'm going to have the height. Let's assume that this is point A, this is point B. So now we have got the bow. So this bow has got the radius, and it is rotating as it is moving. Under work, energy, and power, I want you to understand and remember that we said the mechanical energy initial, which is at point A, will be equal to the mechanical energy at point B. Under conservation of energy, there is no friction at all. So then we'll say potential energy at point A plus potential energy, kinetic energy at point A should be equal to the potential energy at point B plus kinetic energy at point B. Initially, we know that it started from rest, meaning that I don't have kinetic energy at point A. At the same time, when I reach at point B, I don't expect to have potential energy. So this becomes potential energy at point A is equal to kinetic energy at point B. This is the concept under work, energy, and power. Okay? But in this case, we're talking about rotational work, energy, and momentum. So one thing I want you to understand here is very simple and straightforward. Okay? So what I want you to understand here is as the ball is moving from point A to point B, quite okay, we have got velocity, so we expect to have kinetic energy. But we're going to have two types of kinetic energy. There is what we call the translational kinetic energy and rotational kinetic energy. When an object is rotating while moving, then we expect it to have what? Rotational kinetic energy. Translational kinetic energy is the same kinetic energy that you know, that is half mv squared. But the rotational kinetic energy is given by half, okay? It's given by half inertia times angular speed squared. Initially, this is the same because mass is equivalent to inertia. Velocity, the linear velocity is equivalent to angular velocity. Okay, so what happens now is that we use the same concept. Mechanical energy at point A should be equal to mechanical energy at point B. At point A, the only energy that I expect to have, because it was at rest, it was not moving, I expect to have potential energy. At point B, because it was moving, when it is moving and it is rotating, we have got two types of kinetic energy. So at B, we expect to have rotational kinetic energy plus translational kinetic energy. So potential energy is mgh being equal to kinetic energy becomes, which is rotational kinetic energy, becomes I times this squared plus kinetic energy translational, that is half mv squared. The question is, if the ball starts from rest, like we have already said, what is the final linear speed? They want us to find this v. So how can I find that? Remember, I told you that we are talking about a ball. Previously, we were talking about the ball, and we said initially I told you to say this speed you are going to be given is either you should check the first part of the page or the last part of the page. You are going to be given the formula for the inertia. So they are going to give you that maybe the solid sphere, but in this case we're talking about a ball. Okay, So a ball, the formula is 2/5 meters per second, or meters mass times radius squared. Okay, so now I want you to understand that we are going now to replace this mgh being equal to half inertia is 2/5 times this is mass times radius squared. But our goal is to find the v. Remember, I gave you these formulas. V is equal to WR. Okay, so I can divide both sides by R. Even here by R, W is equal to V/R. So where there is W, I can replace it with V/R, but it is squared. I need to square it. Plus half mass V squared. I can simplify this mgh being equal to 1 times 2 is, so 2 and 2 can cancel in simple terms. 2 and 2 can cancel, and that becomes 1 divided by 5. Then I've got m r squared v squared divided by again r squared. So plus half mv squared, like that. At this point, I can go ahead and cancel the what? The r. So now I have m gh being equal to 1/5 mv squared plus half mv squared. I can clearly see that I have got half everywhere, or I have got m everywhere. I can cancel m. If I cancel m, I will remain with gh being equal to 1/5 v squared plus 1/2 v squared. Now I want to add this. To get rid of that, I can just, the common denominator between these two is 10, so I can just do times 10 everywhere. 10 times gh, that becomes 10 gh. Then 10 times 1/5, that becomes 2v squared. 2 there, that becomes 5v squared. I can get rid of this. So mostly this question, they'll give you maybe 10 marks. So I can add these guys, and that becomes 10 gh, that becomes 7 v squared. Divide both sides by 7, then that becomes v squared is equal to 10 gh divided by 7. So I can get square roots both sides. V becomes the square root of 10 gh divided by 7. Let's plug in the values. V is equal to 10 times 9.8 times the h is 12. Then divide that by 7. So V becomes, so I have 9.8 times 10 times 12. I divide this answer by 7. The answer I get the square root. So I'm getting 12.96 meters per second. So that becomes my velocity. Now I want you to look at the remaining questions. That is question 6, question 7, question 8, question 9, question 10. Like I said, these are the most interesting questions. These are the especially if you look at question 7, question 8, question 9, and you need to understand this. So now I've explained this step by step. The video has been uploaded on the website. I want you guys to go on the website and get access to this video. Okay, so if you are not part of us, try to register with us using the link in the description below, and then get access to these videos before your exam, before your test, and believe me, this is going to help you.